Now that we know what the different run levels are and how we can change to a different run level while logged into the system as the root user, we will now show you how to boot into a different run level. Here at the grub menu, we press the A key to append an argument to our kernel boot line. Next, we will enter a 1 at the end of our line, which means that we wish to boot into run level 1. That's all there is to it. Next, press the enter key, and our system will boot into single user mode. All we need to do to boot into another run level is to just append the number for that run level at the end of the kernel's boot arguments. And now we are in single user mode with a root prompt. In single user mode, we can change the root password in the event that we forget it. Just type in the passwd command and press enter. Then enter in a new password for the root user. Now we have a new root user password. If you would rather not have the single user mode automatically log into the root account, you can force single user mode to prompt for a password by modifying the etc sysconfig init file. Now scroll down to the bottom of the file and change the sbin su shell to sbin su login as indicated by the comments above this line. We get an error message stating that vim can't write to the root user's vim info file. That's okay since we are in single user mode, but the change to the file did take effect. And as stated, the root user will be prompted for a password the next time single user mode is run. Let's reboot our system into run level 3. Again, just press the A key, then append the number 3 to the end of the kernel boot line. So how does the system know what services to run in a particular run level? We have already used the check config tool to enable and disable services for a particular run level, so where is that information located on the system? In a moment we will find out. We have already learned that all of our service script files are located in etc init.d. And we have also learned that our etc init rc.conf file starts the scripts for a particular run level. And this file in turn starts the service script files for the designated run level within etc rc.d. Within this directory are the parent directories for our individual run levels. Let's take a look at the scripts for run level 5, which is located in the etc rc.d rc5.d directory. As you can see, we have symbolic links that reference the original service script locations. For instance, we have a script file for the oddjob.d that links back to the original oddjob.d script in etc init.d. But what is the letter and the number for before the service name? Looking through this directory, we have the letter K and S before the service name. The K is for kill and the S is for start. The number following the letter indicates in what order a service should be started or killed. Services prefixed with a lower number get started or killed before those with a higher number. So our oddjob.d daemon is stopped early on in the process of entering run level 5. So what sets this priority? The check config command. Let's use an example. As you can see, the check config output confirms that the oddjob.d service is disabled in run level 5. So let's see what happens when we enable it. And now we see that the oddjob script link has been changed to start with an S, indicating that it will start in run level 5, towards the end of the run level 5 startup process. So now we know what checkconfig is doing in the background to enable and disable our services for specific run levels during the system startup. Take a quick look at the directory for run level 0, the system halt run level. We can see that all service script links are stopped, except for the 2 scripts that actually halt the system. Take a look around these directories on your own and compare what you see to the checkconfig list command to get a good feel for what your system does to start services when your server boots.